Hello, my name is Yossaphan Kaenwong. My student ID is 65364084. So in this video, we introduce network layer 2 or 3. So the objective, we first discuss service that can be provided at the network layer, like packetizing, routing, and forwarding. We then discuss the network layer at the TCP/IP suite. And we then concentrate on the unicast routing and unicast routing protocols. We then move to multicast routing protocol. We finally discuss the new generation of network layer protocols, IPv6 and ICMPv6. So in this section, we show how the network layer is implemented in the TCP/IP protocol. So the protocols is the network layer have gone through several versions. In this section, we concentrate on the current version. In the last section of this chapter, we briefly discussed version 6, which is on the horizon. So in this picture, the position of IP and other network layer protocols in TCP/IP protocol suite. So in the network layer I have a IGMP, ICMP, IP, and ARP. So IPv4 datagram format packets used by the IP are called datagrams. Figure 4.24 shows the IPv4 datagram format. A datagram is a variable range packet consisting of two parts. Fragmentation. I have a maximum transfer unit or MTU and fields related to fragmentation. Security of IPv4 datagrams. I have a packet sniffing, packet modification, IP spoofing, and IPsec. And this picture is the IP datagram. And this is the multiplexing and demultiplexing using the value of the protocol field. And this is a maximum transfer unit or MTU. This is a fragmentation example. The fragmentation is a IP datagram 65,535 bytes. So MTU for LAN 1,500 bytes. A datagram can be fragmented by the source host or any router in the path. The assembly of datagram only by the destination host. The payload of IP datagram is fragmented, not the header. And a fragmented datagram changes the value of three fields: fragmentation, offset, and total range. And this is a detailed fragmentation example. IPv4 addresses. The identifier used in the IP layer of TCP/IP protocol suite to identify the connection of each device to the internet is called the internet address or IP address. An IPv4 address is a 32-bit address that uniquely and universally defines the connection of a host or a router to the internet. The IP address is the address of the connection, not the host or the router, because if the device is moved to another network, the IP address may be changed. And this picture is three different notation in IPv4 addressings. And this is a hierarchy in addressings. The addressing system is hierarchical. A telephone network, a postal network, a 32-bit IPv4 address is also hierarchical, divided only into two parts. I have a prefix and suffix. And this is an occupation of the address space in classful addressing. This is a variable range box in classless addressings, subnetting and supernetting in classful addressings. Not solve the address depletion problem. Long-term solutions is the IPv4 larger address space range increased into the 128-bit alpha numbering value, and the short-term solution is the IPv4 change the distribution of addresses to provide a fair share. And this is the slash notation. ICDR is the classless interdomain routing. And this is the information extraction in classless addressing. And this is a network address. Okay, so in the example 4.5, the number of addresses in a largest subblock which require 170 addresses is not the power of 2. We allocate 178 addresses. The subnet max for this subnet can be found as n1 equals 32 minus log 178 base 2 is equal 25. The first address in this block is 14.24.74.0 and 25. The last address is the 14.24.74.10127 and 25. If we add all addresses in the previous subbox, the result is 208 addresses, which means 48 addresses are left in reserves. The first address in this range is 14.24.74.208. The last address is 14.24.74.255, and we don't know about the prefix range yet. So in figure 4.36 show the configuration of box. We have shows the first address in each box by this picture. And example 4.6, in figure 4.37 show how 4 small blocks of addresses are assigned to the 4 organizations by an ISP. The ISP combines these 4 blocks into one single block and assigns the larger block to the rest of the world. Any packet destined for this larger block should be sent to this ISP. This is a responsibility of the ISP to forward the packet to the appropriate organization. It is similar to routing. We can find a postal network. All packets coming to outside a country are sent first to the capital and then distributed to the corresponding destination. So in this is an example of address aggregation. So in summary, the Internet is made of many networks or links, connected dots, connecting devices, each of which acts as a router or as a switch. 2 types of switching are traditionally used in networking: circuit switching and packet switching. The network layer is designed as a packet switch network. The network layer supervises the handling of packets by the underlying physical networks. The delivery of a packet can be direct or indirect. Two categories of forwarding are defined: forwarding based on the destination address of the IP datagram and forwarding based on the label attached to an IP datagram. An IPv4 is an unreliable connectionless protocol responsible for source to destination delivery. Packets in the IP layer are called datagrams. The identifiers used in the IP layer of the TCP/IP protocol suite are called the IP addresses. An IPv4 address is 32 bits long, divided into two parts, the prefix and the suffix. All addresses in the block have the same prefix. Each address has a different suffix. Thank you.